All right, yeah, I got you.
All right, we're going to do a proof here. What type of triangle does this appear to be? Does it appear to be a 45, 45, 90 or 30, 60, 90? 45, 45, 90. We don't necessarily have proof, but what's the measure of this angle here? 90. And these two are congruent, right? So if they're congruent and they have to add up to 90, they have to be what? 45, okay. So as you can see, this is information that we are deducing, okay? We also know that AC is how long? 10. Okay. So the question is, can we prove that BC is 5 square root of 2? I maintain that we can, because it's a 45, 45, 90. Does this represent side A, B, or C in this triangle? C, right? And the one we're trying to find here represents what? A. You could call it B, but I like to say A. All right, so the question is, how do we do this? So, a rule in 45, 45, 90s is that C equals A times the square root of 2. So, our C is what in this triangle? 10. So what we say is 10 equals A square root of 2. So if we want to get A, we will divide by square root of 2, of course. And that gets us 10 over the square root of 2, because these cancel. A equals 10 over the square root of 2. The issue here being that we can't represent the number in this fashion. It's not that it's incorrect, it's just that it's not the proper formation. So we're going to rewrite it by multiplying out that square root of 2. So it's times the square root of 2 times the square root of 2, getting us 10 square root of 2 over 2, which reduces to 5 square root of 2. Is this what we were expecting to get? Yeah. So we've got this thing. We just got to write it as a proof. Okay, statement. Let's start with some givens. What's some given information in this AC equals 10, absolutely. What else is given? Measure of angle B equals 90. Good.
Measurement angle A and C are...
We don't know what they are, but we know that they are what? Congruent. So what I'm going to say is angle A is congruent to angle C. Given. Okay. Now, we just got to basically retrace our steps. What do the interior angles of triangles always add to? Hello? What do the interior angles of triangles always add to? 180. So what I'm going to say is measure of angle A plus measure of angle B plus measure of angle C has to equal 180. We call that the triangle. No, triangle sum. Theorem. There we go. Triangle sum theorem. Yeah, good job, Larry. Of A, B, and C, which is the only one we know right away? Which is the one that we know?
C.
No. You should not answer these questions incorrectly. They're easy questions. You're just checking to see how alert you are. Measure of angle A plus 90 plus measure of angle C equals 180. 180. So what we did is we replaced the known value. What do you call it when you replace? Substitution. Okay, then we're going to subtract out the 90, and we're going to get measure of angle A plus measure of angle C equals 90. We did some math. What are we going to call that?
PEMDAS.
PEMDAS. Okay. Now, since we don't know angle A and we don't know angle C, we would almost be out of luck, except for one fact. They're the same. If they're the same, we can rewrite the statement as 2 times the measure of angle A equals 90. Are you getting me there? We know this because A and C are equal, so I just replaced C with another A. When you replace something, what do you call it?
Substitution.
Substitution. And if that's true, then we just divide by 2, we get the measure of angle A. So measure of angle A equals what?
45.
45 is correct. What's that called when we do our math? PEMDAS. Okay. I'm also going to use a minor cheat here. Did we already say that A and C have the same value? Yes or no? No. We didn't say they have the same value?
Yes.
We did. So if we know measure of angle A Don't we also know the measurement angle C?
Yeah.
Okay, so I'm going to rewrite this statement as measurement angle A and measurement angle C both equal 45. That's our PEMDAS. Now, all this work was designed to prove to us that we have a 45, 45, 90 triangle. Do we have two 45-degree angles for sure?
Yeah.
Proven. Do we have one 90-degree angle for sure? Yep. So we got our 45, 45, 90. So now we can use our rules. We can say that AC, which is our long side, is equal to BC times the square root of 2. AC equals BC times the square root of 2. Oops. Square root of 2. We call this 45, 45, 90 rules. Okay? Now, which one do we know? Do we know AC or do we know BC? AC. So we're going to replace it with its value. We're going to say 10 equals BC square root of 2. That's called substitution. And then, of course, we're just going to divide by the square root of 2, where we get 10 over the square root of 2. We're going to bury all these math steps under PEMDAS. So we divide, we convert, we end up with our final answer. All of that is PEMDAS. So we get to finish by saying BC does indeed equal 5 square root of 2, PEMDAS, and we're done.